Hey everybody, Mr. Tan in here. Just wanted to go over some quick examples from sections 3.5 and 3.6 for you to watch before you dive into those puzzle times, one or the other or both. But I wanted to just basically demonstrate that you are able to use a lot of the strategies you already know. So remember, when you have a system of equations, we have three processes. We have substitution, we have elimination, and we have graphing. Remember, we could graph them, see where they intersect. Two parabolas, especially, looks like one's going to be opening up and the other's going to be opening down. They could hit twice. They could hit one spot, or they could not hit at all. So I'm not sure what's going to happen here, but let's investigate and see what happens. Substitution could be nice here because they both equal y. So if I substitute this all in for y there, I just basically set them equal. Or elimination also would be nice. I could subtract down, my y's would cancel. I would choose one of those two methods. I'm going to go ahead and just try elimination. I'm going to subtract down to cancel everything out. See how that works out. Y minus y is 0. X minus negative 5. X squared minus negative 5 would be positive 6. Minus 20 would give me negative 24x. Minus, that would be like plus, so plus 18. Oh, look, since it's equals 0, I can divide everything by both sides by 6. It's still going to be 0 equals x squared minus 4x plus 3. Is that factorable fact? Oh yeah, x minus 3 and x minus 1, right? So I've just solved. That was, but remember, when we have this scenario, now it's telling me I have two solutions. Oops. So it's telling me that x could be 3 or 1, but I need to find out what the actual solution is. So when x is 3, what is my output? And then when x is 1, what is my output? Well, the thing is, these are both equal to y, so in this case I could just plug in 3. I would get y would be, in that first case, 3 squared minus 4 times 3 plus 6 be 9 minus 12 plus 6, which would be negative 3 plus 6, which is 3. So the point 3, 3 should be one point of intersection. Then I could plug in 1 into that same equation. Could I have used this one? Yes, I could, because either one should give me the same thing, because we found that this is the point at which they meet. So 1 squared minus 4 times 1 plus 6 would be 1 minus 4 plus 6, which is negative 3 plus 6. Which is 3. Interesting. So I went to Desmos actually to graph this to verify my answer. We had 3, 3, and 1, 3. And check it out. Those two graphs, you can see they intersect at 3, 3, and 1, 3. Those are my two solutions. So graphically, I could use my handheld grapher or Desmos to verify my answer. That one worked out quite nicely. So the other type of problem that I wanted to review here were for 3.6 graphic inequality or quadratic inequalities. And when they say to solve a system of inequalities, they really mean show the graph of it, because there could be, in some case, well, there are infinite many solutions often, especially when you're talking about a point on a plane. Like you could, as long as it's in a portion of a certain portion of the graph, we just need to show that. So I'd like to demonstrate how to solve some of these. So they give us two inequalities, and there was a few little reminders for us to be aware of. Let me put some hash marks here. 1, 2, 3, 4, 5. 2, 3, 4, 5. So it wasn't intentional, but so my first one actually hasn't been shifted at all, but it's definitely going down. It's been stretched by a factor of 2. So instead of going over 1 down 1, because it's negative, it's going over 1 down 2. Instead of going over 2 down 4, because 2 squared is 4, it's going to go down 8. So it'd be somewhere down here. And then this is where I need to think, okay, it's or equal to. So you may remember this from linear inequalities. I use a solid line to graph it. And my fun way of remembering it, if it is the greater than or less than side, if you were to draw somebody standing here, or maybe they're skateboarding, it's fun to think about that way, standing on that parabola, that's always the greater side. Wherever you're drawing the person standing is the greater side. So this is less than, right? So that means I'm going to shade the other side from where my person is, because it's saying less than or equal to. So let me shade down here to show that all of these yellow values, including the solid blue line, satisfies that first inequality. Now let's move on to my second one. Greater than an x squared minus 3. So I'll go down 3. It has only been shifted and it hasn't been stretched. So I go up 1 over 1, over 2, and up 4. That's a pretty good graph, I think. I don't need to do much more than that. Oops, I made my mistake right there. I didn't think. Hold on a second. I got that. I needed to think first, though, about the type of line, because this is just greater than. So anytime it's just greater than or less than, I'm going to have a dotted line, because it doesn't include the values. It's only in this case going to include the ones greater. So let me draw my person, and my person would be on the greater side. So if somebody's standing on here, they would have to stand here. So that's above. It makes sense that that's the greater than side. I mean, another way to think about it is just like, where are the y values greater, and that's above. But that also happens to be where the person would stand, which is kind of fun. And so I would shade above. Let me do in this nice pinkish. So what I'm doing is actually giving the answer graphically. And the solution is the parts that overlap. It's going to include the values on the blue line. And if I want to, I could shade it more in a different color. But it's not including the values on the dotted line. So that's how you would graph a system of quadratic inequalities. You need to think about, how do we graph these equations, give a nice little sketch of it, and then I guess for the puzzle time, do they give you graphs to look at? Let me see. For the 3.6 puzzle time. Oh yeah, that'll be quite nice. They give you the graphs to look at, so you'll just get to check your understanding by doing that. Relatively straightforward. Hope this video was helpful. You'll watch it, tackle some problems, see how much you can get done, do one or both, and hope you have a jolly good weekend. Don't hesitate to reach out, and look forward to seeing you all very soon. Peace and love.